but we're going to talk a little bit more in depth, hopefully make sure that you're comfortable with it before we start a worksheet today. And then we're kind of at the end of what our plan was to cover for this unit, which means that after this we're going to look at reviewing and then testing. So testing probably Tuesday next week, so review Monday, test Tuesday, just a heads up, that's what we're coming into. So for our test, the test will be on piecewise functions, the stuff that we learned about piecewise functions, and then what we've learned about function operations with an emphasis on composition. Okay, so just a heads up on that. All right, so here is our first example. We're going to compose the functions, and we're going to find the domain. Okay, so they're going to give us that the function g of t, they decided to make t what the function was in terms of instead of x, is the square root of 3t plus 5, and then f of t is going to be t squared minus 4t, and they're going to have us find g of f of t. So what does this notation mean? G of f of t. The f goes inside of the g. So I'm going to start by writing down the g. Sorry, I did that backwards. I wanted it to go the other way because I'm trying to make this not as difficult. I actually wrote these backwards. F and then g is what I meant to do. Sorry, guys. Okay, f and then g. So you guys are right. We're going to take the f. We're going to plug it into the g. So I'm going to start by writing down the g, and I'm not going to put the t's there. I'm just going to leave space to plug something in. So something squared minus 4 times something. And since these are my notes, it could be good to write a little note to myself. Plug f into g. Okay. And the thing that I'm plugging into g is going to be the square root of 3t plus 5, the square root of 3t plus 5. And for the first part, what happens? They cancel, right? And what's left over? The 3t plus 5. So the squared and the square root are gone. We have 3t plus 5. And then what happens for the second part? We just take the parentheses away and we write 4 square root 3t plus 5. There's nothing else we can do. We can't put that 4 in there. Okay. Perfect. So this is what we have. Now, for going back and finding the domain, which of these two functions do I look at when I find the domain? Which one? It's the one that I'm plugging in, because domain, so normally when we're looking with students who are kind of new to math, we say, oh, domain is the x values. But the literal definition of domain is it's all of the inputs. So the function that you're inputting is the f. So we're going to look at the f, and f was the square root of 3t plus 5. And what do we know about square root functions that is special with their domain? They don't have asymptotes. Yeah, they can't be negative. They can't be less than 0. So we have to take the part that's underneath the square root sign, the 3t plus 5, and that part has to be greater than 0. It has to be positive. Can it equal 0? Yes, it can equal 0 because you can take the square root of 0. Okay, so how am I going to solve this for t? I'm going to minus 5. Okay, so 3t is greater than or equal to negative 5. And then what am I going to do? Divide by 3. So t is greater than or equal to negative 5/3. So my domain walking into the problem before I even got started, I knew that my domain would at least be t is greater than or equal to negative 5/3. I might get to this and say I should limit it even more, but it can't be less limited than that. Does that make sense? I have to limit it at least that much. Okay, now if I come over here, does this answer tell me I should limit the problem even more? Are there additional square roots in the problem? Is there a fraction in the problem where I have to worry about 0 on the bottom of a fraction? Is there anything additionally that I should watch out for that could make the problem more limited? Yeah, not anything more limited. It's the same amount of limited, right? It still has the square root in it. So it's the same amount of limited, but it's not more limited. So we're going to say this original domain that we found is still going to be the same. I'm going to agree with myself from the start. My original domain is going to be good. Now, I'm not going to write it in this set notation, in this inequality notation. I'm going to write it in the interval notation. Does anyone remember how we would convert that? Okay, negative 5/3 is the smallest it could be because it says t is greater than or equal to negative 5/3. So negative 5/3 to infinity. Infinity is always a parenthesis. And then what is this going to have? Bracket because it says equal to. Okay. How do we feel about that? Yeah? Okay. Let's try another one of these. All right, so we're going to do f of a. F of a is 1 over a plus 4. G of a is a squared minus 5a. And they're going to ask us to find f of g of a. Okay, so how are we working with this one? We're plugging G into the A for F. Okay, so I'm going to start off with F. I'm going to say 1 over, plugging in something for A plus 4. Okay, and then what am I plugging in? A squared minus 5a. Okay, I don't really need the parentheses, so I'm going to rewrite this without the parentheses. A squared minus 5a plus 4. Okay, so there's my answer. I have a rational function once I'm done with my composition. Okay, now I have to go back and I have to find the domain for the function that I'm plugging in, the input function. So if I look at the input function, that was g. My input function was a quadratic. My quadratic domain would be, yeah, negative infinity, positive infinity. There's no limitations for a quadratic function. If you can picture it, it's a U-shape, left arrow, right arrow. It includes everything. Okay? So that's what we know about our input function. Now, if we look at our answer here, does our answer look like it should have limitations? It does, because if we look at our answer here, it has a fraction. We know that with a fraction, you can't have 0 on the bottom of a fraction. So what should we do now that we know we need some limitations for our final answer? What should we do with our final answer to figure out what those limitations should be? You can't have 0 on the bottom, so we're going to take the bottom and do what with it? Not put it on top. We're going to solve it. We're going to set it equal to 0. We're going to set it equal to 0, and we're going to see what makes it equal 0. Whatever makes it equal 0, those are the values we cannot have. Those are the values that will not work. So I'm going to take this. I'm going to say a squared minus 5a plus 4 cannot equal 0, but I'm going to solve for that. What type of problem is this? It's a quadratic. How am I going to solve this type of quadratic? We're going to factor it, right? Oh, that's our favorite. We love some factoring. Okay, so we're looking for two numbers that multiply to a positive 4, but add to a negative 5. Okay, so multiply to a positive 4, add to a negative 5. Negative 4 and negative 1 are the two numbers. So we have a minus 4, a minus 1. And so what are the two values for a? So a cannot equal positive 4, a cannot equal positive 1. Okay, so we have to write down that our domain is everything up to positive 4, but skip positive 4. Or, no, sorry, everything up to positive 1, but skip positive 1. Then everything from positive 1 to positive 4, but skip positive 4. Then everything from positive 4 beyond that. We're going to write it like there's an asymptote there.
So that's where you have like the
We're going to have parentheses with the specific number. Okay, so how do I write all the numbers less than positive 1? How do I write that in that interval notation? Okay, negative infinity to 1 with parentheses. Okay, how do I write all the numbers between 1 and 4? We got to put a U because we have another answer. And now what am I going to write? 1 to 4, okay. And then do another U. Perfect. So this is how we write it. Everything but skip the 1, everything but skip the 4. Okay. So when we looked at our input function had no limitations. Our final answer had a couple limitations because it was a fraction and you can't divide by 0. No zeros on the bottom of a fraction. All right, how do our brains feel about that one? Could we recognize that we needed to look a little bit more on that one? Okay. So this is actually, yeah, let's write down what we need to look for. So with domain, let's write a note to ourselves up here. What are the functions where we don't have to worry about them for the domain? So all real numbers for the domain are quadratic. What else is all real numbers? Exponential. Absolute value. Cubic. I wrote absval as one word. Absolute value. Cubic. Cube root. Okay. And then what are the ones we have to worry about? Square root. And rational. So with the square root, we have the inside is greater than or equal to 0. With the rational, we have the bottom cannot equal 0. So square root, the inside is greater than or equal to 0. Rational, the bottom cannot equal 0. Everything else that we've learned, quadratic, exponential, absolute value, cubic, cube root, those are all real numbers. Okay. The part underneath the square root.
Oh, okay.
Okay. So these are the two we're going to watch out for on this assignment. Okay. Let's try another one. So for this one, we're going to have f of n is 1 over n. G of n is the square root of n plus 9. And we're going to find f of g of n. Huh? Oh. Thank you. Okay. They all end up on the floor. All right. So, what do we need to start with? The G goes into the F. So I'm going to start with F. I've got 1 over... And then the whole thing's going to get plugged in, right? The whole thing's going to go down there. Okay? And it's the G that's going to go down there. N plus 9. Okay? So we are done with that. Yeah, so if we look at this, now what I'll say for this is a good answer, but some people would do what is called rationalize. Some people would rationalize this because some people don't like when there's a radical on the bottom of a fraction. So this would be an okay answer maybe, but they also might fix it. So if we didn't want a radical on the bottom of a fraction, how could we fix that? We can't just raise it to the second power. Sorry.
You do the inverse of the thing.
Not the inverse. Not quite. Well, think about what if you had like 1 over root 2? How do you fix that so there's no radical on the bottom? Anyone remember?
The opposite.
Not the opposite.
I feel like I know it, but I don't know. Like it's somewhere in my brain. And you can't. I just cannot remember. Yeah. Okay. If you do what I just said, you're not.
Is this ringing a bell?
Okay, that is what I meant when I said that. That is what I meant.
So you multiply it by the radical that it is on the top and the bottom. It changes what the problem looks like, but it doesn't change what the problem represents. So it's going to look different, but it's still going to represent the same thing. This is called rationalizing, and it just makes it more proper. So some people require it, some people don't. The only time it would matter, really, is one, if you had instructions in the problem that say to rationalize your answer, or if you're taking a multiple choice test and this was not a multiple choice option and you only had options where there was no square root in the bottom and you didn't know like how they got that, then it would be important to know how to do this. So it's possible that they would ask you to do that. Okay, so if this is our problem, we're going to say we're done here. This is our answer. But let's go back and find the domain. So we know that the piece that we're looking at, the piece we plugged in, is G. G is the square root of n plus 9. And so how are we going to find the domain of the input function? So the inside has to be greater than or equal to 0. Okay? The inside is greater than or equal to 0. And so what am I going to do to solve for n? Subtract 9. Okay? So n is greater than or equal to negative 9. Okay. So now we've got what we think the domain might be. Now I'm going to look at my final answer. And I know that my domain should at least be this limited. But should it be more limited than that based on my final answer? Yes, because I can't have 0. Does everyone know? Carly, don't say anything. Does everyone know what Carly means by that?
Yes.
What does she mean?
That there can't be a 0 in there?
Yeah. What is she saying?
Because if you put the 0 on the bottom and it equals 0 and there's a 1 on the top, what is, you can't do it.
Okay, so I know what that means, but I'm not sure that everybody else is tracking with you.
I got it. No. I understand. Restate it for
Yeah, I know what you mean. Can somebody else rephrase that?
I'm right, is what it says.
We can't divide by 0. So right now, the domain that we have says the n plus 9 is greater than or equal to 0. We're including 0 as a possible answer choice for this domain. But this got put on the bottom of a fraction. What can you not have on the bottom of a fraction? You cannot have 0. So how should we adjust this to reflect that this answer is now on the bottom of a fraction where you cannot have 0? How should we fix this? Because this said n plus 9 is greater than or equal to 0. Take away the equal to. So this was greater than or equal to 0, but then we put it on the bottom of a fraction where we're not allowed to equal 0. So if we go back over here, if we erase the equal to, and we erase the equal to, then we're saying, okay, this was greater than or equal to 0, but this cannot equal 0. So as long as we're just greater than 0, we're going to be okay. So we've got the square root of positive numbers only. Not the square root of 0, that doesn't work. Just the square root of positive numbers. Does that make sense? We took away 0 as a possible choice. All right, so my domain is going to be what? How should I write it? -9 to infinity, and the -9 gets bracket or parenthesis? Parenthesis. It would have gotten a bracket before, but we had to take away the bracket, right? We don't want to equal -9 exactly, because if we equal -9 exactly, we're going to get 0 on the bottom of a fraction. That would be a problem. Okay, I got one last problem for you guys. All right, we've got g of x is -x squared plus 9x. H of x is x minus 2. And we're going to find g of h of x. Okay, so what do we have to do? The h is being plugged into the g, so I'm going to start with negative, plug something in for x squared plus 9, plug something in for x. Okay, and then the thing that I'm plugging in for x is x minus 2, x minus 2. Okay? And the trick here is, how do you actually multiply all this out? Do you distribute the negative? Do you distribute the 2?
You have to write the negative and then separate the thing.
Okay, so if you distribute the negative, you're going to get the problem wrong. So don't distribute the negative. The exponent, the exponent we do first. Why do we know that we should do the exponent first? PEMDAS, order of operations, tells you deal with the inside of the parentheses first. You can't do that because these are not like terms, so we're going to ignore that step. The second step is the E, which means exponents. The third step is multiplication. That is the negative. The negative is multiplication. That's the third step. So second step is exponents. That's what we're going to do, is the x minus 2 and the x minus 2. We're dealing with our exponent. Now with the multiplication step, you don't get to take this negative 1 here and just bounce it to everything. When you multiply stuff, you only get to multiply 2 things together. So you could take the negative and multiply it to the first set of parentheses, or you could take the negative and multiply it to the second set of parentheses, but you don't get to multiply it to both. Okay? Let me make it a little bit more clear to you. If we were multiplying 2 times 3 times 5, you would not take the 2 and distribute it to the 3 and the 5. If you take the negative and apply it to both of these parentheses, that's exactly what you're doing, is taking the 2 and distributing it to the 3 and the 5. Do you see the problem there?
Yes.
Okay. So what I typically tell students to do is FOIL this out first and distribute the negative after that, because you're more likely to get the right answer if you do that. Okay? So let's go ahead and do the foiling first. So what do we get if we FOIL?
I have a question.
Mm-hmm.
When you FOIL it, you don't switch one of the signs to like a positive or just
No.
negative?
Nope, because it's squared, so they're saying the exact same parentheses twice.
Okay.
So x times x is x squared. Then what do we have? Minus 2x. Minus 2x. Plus 4. Okay, so we've got x squared minus 4x plus 4. And then what about this part over here on the end? Okay, 9x minus 18. Okay, and then if we distribute the negative, what do we have?
Negative x squared plus 4x minus.
Okay, so now we've got what?
Negative x squared plus 13x minus 22.
Okay, so we have a quadratic as our final answer. Let's look at our input. Our input was h. H was x minus 2, so that's y equals mx plus b form. That's a straight line. So what is the domain of a straight line? Okay. So we started off with the domain of a straight line, all real numbers. Over here, we ended up with a quadratic. Same thing. So our domain is all real numbers here. Okay. Are there any questions I can answer about the domain? Any questions that came up about the domain of any of the problems? Okay. When I made the worksheet, I tried to give you some problems where the domain would make you think a little bit, but not make you want to cry or stab your eye. That was my goal. Make you think a little bit, but not make you hate your life. So we have this worksheet. There are 18 problems. Work on them. Let me know if you think the worksheet is too much, and we will reduce it if necessary. Okay?